All right. So now, okay, can people see me? We should be live. Um, as soon as somebody sees me and hears me, uh, please report in so that I will know. Okay, cool. Ben says we are loud and clear. All right. So now I'm just waiting for the top of the hour so that people who tuned in late are not discovering that they should have tuned in early. And we'll get started. Great, Violetta. Thank you, Daniel. So for the next, there's a little echo. The sound is oddly reverbed. I don't know what I can do about that. Testing, testing. Uh, yeah, I think we're just stuck with what we got. I am in a small cabin, and I think the sound's just actually reverbing in here. Um, okay, good, good. All right, and my clock says 5 till the hour. We'll start right at the hour. Uh, if you're watching this and you're seeing this on the recording, I am I am going to cut this off. So if you come back in whatever time it takes me to do that, I will have it start right at the start. And maybe some of you will get to see me tonight, discover that I'm not actually a brown colored robot. You can hear the Slack sounds. Yeah, I may have to figure out how to. Oh, oh, good. Okay, I managed to mute the Slack notations. Am I muting my? Oh, that's a good idea. Hang on. Hey, did this improve the audio quality? Did this improve the audio? Testing. Did that improve the audio? Somebody speak to me of improved audio. Audio still exists, but it still has the echo. I think Brendan might have a good idea. I turned. Yes. Okay. Cool. All right. We have learned. Yay. Okay. Well, yes, I will. In the future, I will save. I will not add all three of those. Okay. I'm going to switch the webcam for a moment just so that I can. Yeah, and that changed with it. Okay, cool. So the quality is good. That's good. Yes, does for me. Okay, testing audio. There is a significant lag for the audio. I'm aware of it, and that's just part of streaming to YouTube. And I will definitely allow for it when I ask a question. I will put a pause in. Okay, and I think we and as soon as that motorcycle group goes by, we'll get started. Okay, and welcome to first lecture of Sweet Prolog Beginners class. And we're going to have a chance tonight to explore some Prolog kind of for the first time 1 week into class. And so I want to start with a little bit of explanation. So I'm going to go back to the screen, and I'm going to show you this diagram. This is kind of the big parts of Prolog. Prolog is a query language. You start by asking a query. You then you say, what things can I, or you ask, is this true? And usually in the course of figuring out if something is true, if it can be proven, then Prolog will do a couple of things. One, it may have some side effects that are useful, typical sort of functional programming side effects thing, or it may have or it may say, yes, it's true for this value, which is often useful. So those are the usual two modes we might run Prolog in. So that means we're going to have two things. We're going to have a query, the thing we're asking, And we're going to have a bunch of facts and rules. If you've done the DIKW pyramid, you know that ultimately you end up saying, oh, rules are useful for inferring more information. And we call our rules the knowledge base. There is a linguistic difference between facts and rules in this, but in actuality, they're very much the same. A fact is just a rule that isn't whose condition is true, so they're always true. Okay. So those are the two parts that the Prolog search engine then will operate on. So in effect, Prolog only runs one program. We can say Java only runs one program. The JVM runtime, the JVM, interpreter that interprets class files. For Prolog, we only do one thing. It's called SLD resolution, and we'll spend all next week on it. So we have to have these two pieces. Where do they come from? Well, the query is what you type at the interactor. Here is my terminal. Is that big enough for everybody? Say so if I need to bump that up. So if I start Sweet Prolog, this is an interactor. And I can do things like I can ask for what values of x is x a member of the list A, B, C. And it will tell me A. And then it will blink at me like this. It won't give me another question mark minus prompt for another query. And instead, it will stop and blink at me like this. And that's because it suspects it might have more solutions for x. And of course, B is also a member of the list ABC, and so is C. And in this case, it figured out it had no more, so it just stops with C. Sometimes you'll see it stop, and then it'll say, oh, I don't actually have any more. We'll talk about the hammer story. That is the interactor. A few practical things. It has pretty much readline capability. We compile with either readline or edit line. Readline is GPL'd, so we compile with edit line. And if you really need full readline, you have to do that yourself. How do you stop them? Well, how do you stop Prolog? You can query a thing called halt. And halt has the useful side effect that it stops Sweet Prolog. Okay. That's how you get the hey, would somebody respond to whoever came up on announcements and invite them to join the lecture that's in progress? That would be a cool thing to do. So that gets us the query. I've had a couple of students ask me, so can I type code in at this question mark minus sign? And basically the answer is no. It's not a REPL. It's an interactor. You're in a query language, and there's two parts. The query is for over here. The other part you're going to need is a knowledge base. A knowledge base is an internal set of representations of rules. That's what it is. There's no separate notion of data in Prolog. Code is data. So whatever you have in your knowledge base is your knowledge. And where does that come from, though? Well, when you start up Sweet Prolog, somehow it's got to load that in. And the process it does that by is called consultation. Am I going too fast for people? How's the pacing here? Are people good? People following along? Give me some baffleometry here. So, okay. So how would I start? I would start Sweet Prolog with SWIPL, SWIPL, and then the name of the file that I want to bring in. Bringing in this file, I don't know if I said that, is a process called consultation, which is probably a bit pretentious at the time, but it's what we got. So, okay. All right. Anytime you can reconsult, reconsult your file. For example, if you're changing your files with an external editor, this is very handy. There's a built-in make. It'll figure out which files have changed and reload those that have. This, by the way, makes Prolog extremely hot swappable. You can, in practice, actually practically do changes on the fly and not have to re-enter like user input. If you have, you get into this awful thing where like there are 6 steps of user input and then something breaks, and debugging that is a mess because you have to redo the user input. So you do some hacky thing like hacking in the user input, or you just suffer with it. Don't have to with Prolog. As long as you aren't storing your data in the module that you are reconsulting, it'll stay there. A more subtle point is that, of course, this is reconsulting, and it won't end up with like 2 copies of things. If you change something, otherwise it would say, well, that's not the same as the old one, and it would leave the old one and give you the new one. Okay, everybody happy with this? And then usually there is something that will start the thing off. You can make queries here. Well, I've just added now this little program that solves one of these river crossing puzzles. And hey, I can run my river crossing puzzle. Get several solutions, get tired of looking at solutions, and I hit period, and it quits offering me more solutions. Okay, so while I'm kind of on the subject of the Sweet Prolog environment, I'm going to show you a couple of other pieces. This is a little built-in editor. I think you've all seen it because I asked you to use it to make certain your graphics were working. Well, that's fine, but a far more convenient use for real work is to say edit. And this will bring it up. Oops. Your YouTube's pretty choppy on your end. Excuse me. How is it for everybody else? I heard lots of really good earlier. So, okay. This is the little editor. I'm going to go back and do something, however, just basically because I forgot to mention it. And that is, you'll notice there's a period on the end of everything. Prolog does everything in terms. And when you type in something you want when you type in something that is a term, Prolog needs to know where it ends, and so you type a period. So, okay, and that is going to be true within files as well. So you'll get really used to typing periods. Audio is good, video is a bit choppy and bearable. I think that's where we want to be. It's the audio that's important. Okay. Semi-transparency of the console has some flickering. Ooh, the console is indeed semi-transparent. I don't know why that is. I'll figure it out. But I'm not going to do it now. Half an hour digging through the terminal stuff is not where we need to be. So, okay. So I invite you to follow along at this point. There is a file called Adults Children in the lecture 1 in the students folder in Google Drive. And if you have Sweet Prolog installed, stick it in some directory, change to that directory, and then do what we said before. Swipple space and the file name. Note that your life will just be saner if you start this from the directory that the file is in. So why edit if you have make with an editor that doesn't hate humans? So the little editor, you can take it or leave it. It has the advantage of being really good about finding mistakes in your Prolog. So even if you're using something else, looking at it in the built-in editor can be worthwhile. But you're perfectly free to use any editor you want. The reason I insisted everybody make certain it was running was for something else, which is the graphic debugger. Okay, we have seen this little program run. I'm going to give it just a moment, again, kind of slow down for everybody to grab that file. And then we have seen this program run. And the way you run this program is you ask whether go is true. And it runs the program as a side effect. So, Norbert, the reason I wanted you to make certain their editor was working is so you could make sure the graphic debugger was working, and it was easier to give directions to start the editor. So, if everybody's got the file at this point, I apologize for not sort of saying that before that you need. And while you're there, grab the file called units.pl. In fact, should I start with units? No, no, I'm going to start with this. Okay, so when you start it, it prints out a set of moves for a boat. For the little problem, you have a small boat. It can take only one child and an adult, or two children, or a child and a dog. You have 3 adults, 2 children, and a dog on one bank, the left bank, and you want to move them all to the right bank. So I'm going to look at my code, and Wow, Prolog code. Okay. This first line, everything in Prolog is one of two things. It's either a comment or it's a term followed by a period. So this is actually a term followed by a period. The colon minus is what's called a directive, but it's simply an operator, and says run this at compile time, or at consult time, when you reach this point. Hey Norbert, did I answer your question? Okay. So what I'm going to do now is I'm going to start the graphic debugger, and then I will trace through this program and kind of show you the flow of how Prolog reasons about things. So there's a couple of ways to start the debugger. One way is to put a spy point on Go. That would do it. The other way is you can insert a call to the library predicate gtrace anywhere in your code where you want to break into it. So in this case, that's what I'm going to do. I'm going to say, hey, can you prove that gtrace and Go is true? And Prolog will naively go out, fire off gtrace, which will drop it into the debugger, and then it will attempt to debug Go. Boom. Okay. So, all right, we got green. Space gives us in. S gives us over. And then you all know this painful thing with debugging where it's like, oh, I don't think it's that, and you hit S, 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 and after half an hour of like being in the middle of chasing this thing down, you hit S one too many times, and darn it, you went over it. And now you have to start again. Well, with Prolog, you don't have to do that. Because with Prolog, if you do that, you can hit R, and it'll back up one predicate, and let you run it again. Of course, if you have side effects, the side effects will be repeated, but can't have everything. Okay. So this says Go is true if, and yes, I'm going to be, I wanted people to see Prolog before they really started studying it in detail, so I am showing you a bunch of code without having introduced a lot of this stuff. So don't worry if your baffleometer goes up. So Go is defined as true if init is true for some value of init, and the crossing plan for that value of init is a plan called plan, and write plan is true for some init and plan. All right, and hey, this looks like imperative code, and that's because it pretty much is. Init is true. Well, I only have one condition that can make init true, and that's if its argument is this thing, which is a compound term or complex term. We use both terms. Sorry, I got too many characters in there. I want to show you this. This, which means I am on the left, and there are 3 adults, 2 children, and 1 dog on the right, or on the left bank. So, okay. So that's the only way in which init can be true. So hey, init is now true when it's this complex term. Okay, and of course when I run this, I'm going to get a plan. I'm going to step over it at first to show you that I do get a plan. Hey, I do. The plan, you can double click. I double click there to get this to come up. The plan is a whole bunch of moves. A move from left to right of two children. Then have one of the children row back. Then move one of the adults. And then have a child run out. Yes. Okay. The keys I am pressing, I'm going to restart this anyway. So I am hitting R. That's the R key. And that gets me back up to here, to the start of whatever I'm in. Space bar gets me in. And then I could hit spacebar and go in, but going into init is not very interesting, so I go S and go over it. Okay, and now I'm going to go S and go over it again, and I will show you this, which I got by double clicking on this spot on this thing. And if you double click anywhere in there, this is the local bindings. Essentially all variables are local scope in Prolog, so that's the only scope there is. Over here is the call stack, but since we're in Prolog, this gets a lot hairier than a normal call stack, which we'll soon see. And then here, this is just a good way to inspect a single variable, laid out for pretty printing. Okay, and then this one, of course, will write the thing out. That's a little less interesting. I'm going to go back. I'm going to hit R again and restart. Okay, I have restarted. I hit space and go into it. And then this time I'm going to hit space, and we will look to see how it makes a crossing plan. Okay. Now, here's a note, an important comment. I will tell you, good comments are important in Prolog because the language is so flexible that it gives you sometimes relatively few clues what's going on if you use single character variable names and don't provide comments about what's going on. Okay. Arg states is a list of complex terms, left, adults, children, and dogs, on the left bank, and right, ACD, where the members are still for the left bank, but the boat's on the right. Okay? So we're always going to keep track of how many people are on the left bank. All right? Okay. And we've asked, what is a crossing plan? Our program provides 3 ways of making a crossing plan. The first is that the plan starts with no one on the left bank, in which case we're done. Everybody get that? That's a little more woo-woo. Everybody get the notion that if the list of states starts with nobody on the left bank, we're done. Okay, cool. All right. My next trick is there's only really 4 legal moves. The next clause is if the boat's on the left bank, that is our last state. Our state is that the boat is on the left bank, and we have some number of adults, children, and dogs, presumably not 0, or we already would have handled it. And we, and then the third clause is if the boat's on the right bank. So for now, we're stuck on the left bank, so we're going to be in this clause. Member is a built-in library predicate that just is true if its first argument is a member of its second argument. So we say, are there any solutions for move, or move as a, right? This is the thing I demoed before. And yes, it's going to give us the first one. So the truth is that there aren't that many different ways to do this. You can put an adult in. You can put a child in. You can put 2 children in. You can put a child and a dog. That, it turns out, is the only possible legal moves. So, okay. So I have a move. The next line does destructuring. If you know Clojure or Haskell or Scala, I think, you're going to have seen destructuring. And this is simply, I need the numbers out of this complex term. So I'm going to do something sneaky. I'm going to say, what term LR with 3 arguments, what 3 arguments would be the same as move? And of course, that just gives me the 3 arguments in those 3 variables. They've got to be those 3 numbers. The next problem we've got is, do we actually have enough people on the left bank to make this move? We can't move an adult over if there are no adults left. Can't move the dog over if there's no dog left. We've got the dog on the right bank already. So we'll check that for adults, children, and dogs. And now we're going to figure out what the new state is. And gosh, that's actually not all that complicated, right? We're just going to move the people over. Okay, so I've got a move and I've got the original state. Notice I've kind of remade my structure here out of A, C, and D, just because that's what I had. So, okay. I will subtract off the number of people in the boat, and I will move the boat to the right. Okay? And new state will be true if the last argument is the result of doing the move that's the second argument on the first argument. There we go. Okay. So, we have a new state, which is on the right, with 2 adults, 2 children, and a dog. So what have we done? We have moved 1 adult across the river. Now, question for the audience. Is this a smart move? I will wait the 10 seconds. Are you guys out there? And what do you think? I see somebody typing. \+ means not. And no. Yeah, because the only thing you can do with that adult is have them row back across. But we've got a computer, and it makes poor decisions. Not a good move, no. So, okay. So the next line says, yep, it's a no-op. Okay, so the next line says, is this new state in our list of previous states? And the truth is, and the reason we want to check for this, and the reason we haul our entire history of states with us, is because otherwise the computer would foolishly move the adult over, realize it's not a good idea, and move the adult back, move the adult over, move the adult back, move the adult over, move the adult back, and this would go on forever. So, I want to say, is it provable that the new state is in the old state? And if it is, and then I want to invert that. So I want to say, is it not provable? And at some point we'll discuss open and closed world and negation is failure. So, but not today. So, okay. So this is actually only good. This is only a solution if it fails, right? If there is no solution. Yeah? Okay. So it's red, which means there was no solution, which makes sense. We just have the initial position, and past in this case is going to be nothing. So we just have the initial position to test for. So since that was false, the not means that it succeeds, and we can try another move. Now we're going to recurse. When we recurse, the boat's now on the right-hand side. So we want to use the rule for the right-hand side. Okay. And there's really only two useful things. This is a good point about Prolog, is having a proof search doesn't mean your domain knowledge is useless. Prolog will do its depth first search thing, but in this case, there is no point. Let me ask you: is there ever a point? Is there ever anything to be gained by an adult rowing back across the river? And waiting for the 10 seconds. No. Okay, yay. No, there's no point. So we don't even include it in the possible rules. Yes? No, Norbert, there is no point. Yeah. Yeah, the adult could ride with a child, but then the only way the adult can get back is, again, with the same child. Right. We want movement to the right of adults. So, okay. So the only reasonable things to do are get 2 children on the left bank or 1 child on the left bank. The same argument that holds for the adults holds for the dog. Right? The dog can't row itself, so it's not going to be useful as a conveyor of other things. Okay, so I'm going to ask for one of these 2. Now, you'll observe something here. This is my stack, but what the heck? It's not a list of things. It's some complicated set of stuff. Remember that in the previous frame, we can actually go back to the previous frame. We were on the left bank, and we, up here, we chose one of these 4 first moves. Now we're down here, and again, we've chosen one of 2 moves. So that means there are some other possibilities that we didn't take. So this now is very much the same. We need to get the initial number of people because we're always tracking number of people on the left, so we have to do a little bit of math with the total number of people to make certain we have enough people. Oop. And I'm going to do that again. And I hit R to do that again. And okay. And our plan is we're going to move 2 children from the right to the left. That's our planned move. We have a little problem with that. We have 2 children total, and we have 2 children on the left bank. So there are no children on the right bank. And I can't put 2 children in the boat if there are no children on the right bank. So when I hit S, and this time it's red. This is called a failure. Now what's going to happen? Well, what's going to happen is it's going to back up. Prolog can execute backwards. And it will undo all the computation it's done since the last choice point. Where's the last choice point? Where's the last time we had a choice? Anybody know where our last choice of action was? I'll wait. Jonathan, I see you typing. Go ahead and hit return so we can go on. Several people are typing. More typing? Yep. And the sound hangs. Okay. Hey, I'm going to try turning down. Yeah, I'm monitoring my internet availability. I'm going to try turning down my settings. Okay. Hopefully, let me know when I'm back. Please let me know when I'm back. This should be happier if a little lower intrinsic quality. Yay, I'm back. Okay, cool. All right. Cool. Okay, this should give us better quality. I'm sorry, I was a little too aggressive about the quality settings on the streaming. Okay, so here I'm going to go do this again because we were right at a crucial point. And remember that we moved an adult over the right bank, and now we're trying to move two children back to the left bank, and we've discovered that we don't have two children in the right bank to do that. So the question is, where is the last place? So Prolog is going to fail. It's going to say, I can't do that. Excuse me. So it's going to back up. Now, what was the last choice we had? And I will take my question on the air. I will take my answer on the air. Where was the last place that we had a choice? Yeah, specifically the most recent call to member. That is when we had a choice of moving one child or two children from the right to the left. Yep. Remember that we've called member twice. If you look up here, you'll see, in fact, we've got two of them in the stack. So the next thing that's going to happen, I'm going to hit space. So LR, and it's going to back up. Now watch this space, what move is. Okay. And hey, it's going to back up. It's going to undo all the computation it's done since that member. And now it's going to bind move. It's going to try giving me a different proof. This is why Prolog will give you different proofs at the top level. It's because it's treating you the same way it's treating everybody else. That is, everything does this trick of giving you multiple proofs. In fact, this is Prolog's only control structure. This is the only way to influence flow of control, flow of execution. So, okay, now we got one child, and I'm not going to wait for it, but you can predict what's going to happen here. We don't have one child either. But this time, we don't have any more solutions in member. We tried the last one. So where's it going to back up to? When I hit space, it's going to back all the way up to the previous move. And say, this did not work. Since I can't make a crossing plan, starting with an adult moving over, it's going to keep failing backwards, and I'm going to roll this down a little so we can see the member, and notice it tried one adult and no children and no dog. That's what move is, one level up in the stack, and then we go back to the member. I will hit S, we will go over, and this time it will offer to move one child. That's a more reasonable choice. We will destructure that. We have enough people to do that. That is not in our previous list. We're making progress. And now I have a child. This time I can, again, I'm hitting S. Sorry, I hit space to get into this thing. I'm hitting S to get over. This time, of course, I don't have 2 children, but when I back up and it gives me 1 child, it will succeed. We've got enough folks to do this move. We can figure out what the new move is. And I hit S, and it's not detected a loop yet. But now that doesn't get us anywhere either, because all we did was row a child across the river and then row it back. Okay? And so this goes. Obviously, we could be here quite some time if I just ran this. I'm going to hit F, which runs until we finish. That's F as in Fred. F. I wanted to hit F in there. I ended up with F on member. And you'll note, in fact, that at this point, I have a stack of 23 choices of member back in, because we're making a plan. And now I'm going to go all the way back up to the top, and I still have all those choices in case I want to back up. And you'll remember when I started this, I demoed the program and I just ran it, and I told you about the semicolon to give us extra copies of the plan. Write plan is not very interesting. It's just recursive. It's just a recursion that goes through the list and prints the elements. And so I'm going to hit S and go over it, and I will hit a space. So that's my little demo. And I think I'm comfortable with what I did here. I had another program in the waiting, but I'm not going to use it tonight. Somebody's asking a question, or I see typing going on. So, comments? I realize I showed you a lot of material that I didn't prep you for tonight, but the fact is that all the learning dependencies for Prolog make a nice loop. Charles, yeah, I mean, of course, eventually that would bite us. I actually, I have another river problem that I've expanded so that you can put in any size of canoe, and it's one of these. It's the old cannibals and missionaries problem, and I expanded it so you could have any size canoe, and then when it turns out there are lots more combinations as the canoe gets bigger, so you need to so I had to change some code. A nice thing about Prolog is you can do these things as facts, and then if you if some of your things are just facts, and then there's this other case and I have to get it out of the database, Well, then you just add a new clause and say, here's a new rule for how to do this, which is to get it out of the database. And you might do that deliberately. For example, suppose you just kind of know that 90% of the time this lookup table is looking for one of these 4 values, and the other time it's some one of a row out of the database. So now maybe I've misunderstood your question. Are you suggesting we solve canoes of any size and any sort of rules about their behavior, and then pick the specific one we have? That's not going to execute very efficiently. Prolog's kind of cool, but not magical, and definitely would spend a lot of time grinding through search space. Other questions? Cool. Okay. Thanks, Charles. Do we have other questions? If not, we're probably good. Do you put the code somewhere? Yes, Norbert, it's in lecture 1, in week 1, in your student drive. No, actually, it's just in week 1 of your student drive. Yes, there is a way to do test-driven development. You can, there is a system for doing this called PL Unit, which in fact coolly it looks through the code and assumes that anything that any predicate that starts with the name test is a test. So that's rather clever. But yeah, there's a system called PL Unit. There's also a Prolog binding to the test anything protocol as a pack. Packs are like gems. Okay. Yay. All right. And I think we're pretty much at the end of it then. I will keep answering questions by chat on in the Pound Lectures thing, but I'm going to turn the streaming off now.